All right, everybody. So this is the week 7, lecture 1, and this is mostly going to be optional if you have attended lecture in week 7. So in week 7, we're going to be doing lab 7, week 7, of course, and there is also a homework assignment that to do and over the next week. Anyway, if you are in the lab today, then you probably will not need to watch this lecture video. However, this is for people who are missing class or just want an extra piece of information. Now, regarding this, like you'll see that I have linked something here called notes. It says notes fit a polynomial using systems of equations. And yeah, that's what we're going to be doing today. But it's not lecture slides. And that's because in the lecture slides, it's hard to typeset math. And so I made a page instead of lecture slides for today. Regardless, this is what we're doing. So we're going to look over how to fit a polynomial to some data, right? So let us just open up maybe in Desmos or something here. Um, Desmos.com is just a graphing calculator, basically. So I will kind of refer to this as we're going. Back over here, I want to open up my notes. Okay, so let's do that. And this is what we have instead of lecture slides for today. I'll make them bigger. Now, what you should already know how to do before we start here is like how to represent a linear system of equations in MATLAB, because that was gone over last week and in the previous lecture slides. So if you don't, then this is an example of that. So here's a simple system of equations. A system of equations is just one or more equations. I guess you would want more than one, right? Because if it was simply one equation, you wouldn't call that a system. You would just call that an equation. So this system of equations is two equations with two variables, x and y. Okay, and what we want to do is figure out what is x and what is y. And you should be able to do this by hand, and we might do some of that today in class, but we can also solve it in MATLAB now, right? Or Octave in our case. So I'll open up the terminal here. No, I won't. I don't want the terminal. I don't know why I opened up a terminal. Um, we'll open up Octave. Oh, I remember, because similar symbol in the icon to the terminal. That's why I opened up the terminal. All right. So just to remind us, right? If I wanted to solve this system of equation, the first thing I would do is I would make the coefficient matrix, which we normally call A. And in the A, typing up here, we just need to get the coefficients from the left-hand side of these equations. So on the top equation, the coefficients are 1x plus 1y. So we go 1, 1, semicolon to go to the next row. And then in the second equation, the coefficients are 2 and negative 1, right? So there's a minus there, so that would make it negative. So we have 2 and negative 1. So here's my system, or sorry, my coefficient matrix for my system of equations. Now, similarly, we have to type in the b, and the b is going to be 2, 10. Those are going to be the constant vector, the b. So in ax equals b, the b is the coefficients, not coefficients, the constants that are on the right side of the equation, which is where we put the constants. I did it again. I opened up the wrong thing. Here we go. So we just need 210. So we go 2, you can do 210 and then an apostrophe if you want. We need it to be a column. So this is my system of equations. Then to solve it, there's various ways. One way is x equals a, and then a backslash, and then a b, and we get 4, negative 2. Another way to do it would have been x equals the inverse of a times b, and you'll just get the same answer. Okay, so we should already be familiar with that before starting today's lab. Now, what we kind of want to talk about today, and this is not really the best way, like polynomial interpolation is not something we're going to do a bunch of. The reason we're doing it now is because it's a good example of a system of equations. Now, there are problems with polynomial interpolation that makes it so that you don't want to use it. You want to use some other type of interpolation, but we can use it, right? And so when we talk about polynomial interpolation, what it means is we've got a polynomial. So in this case, right, here's an example polynomial, f of x equals ax cubed plus bx squared plus cx plus d. So this is a, a third degree polynomial. And what we could ask ourselves is, uh, what would the a, the b, the c, and the d need to be for something specific to happen? So, for example, what if I want f of 0 to be -4? How could I do that? What if I want f of 1 to be -4? How could I do that? What if I want f of -1 to be -10 and f of 2 to be 2? Now you can show this over here on Desmos, because if we have f of 0 equals -4, what we're saying is that there's an x value of 0 and a y value of -4. So we can like put that point on there. Maybe I can make this bigger, I think. Let me figure this out. Where's the settings? Here. Zoom is in the way. Bigger. Okay, so I just have that point, 0, -4. And the next one has an x value of 1 and also -4. So we can go -1. Was it 1, -4? I already forgot what I looked at. It was +1, -4. So we can change that. And then we had another point, which was -1, -10. And then I can have a fourth point, 2, 2. 2, 2. We can label all of them. So these are just several points, right? So we just have several points on the graph, and I've put them, well, they're, I don't know, pretty close together on the x-axis. I was just putting in easy numbers, 0, 1, -1, 2. And so if there are 4 of these points, then you have 4 equations here that you could satisfy. And with 4 equations, you would be able to uniquely find 4 constants, the a, the b, the c, and the d. So the fact that we have 4 pieces of data and we have 4 unknown constants, those are related facts. Okay. Now, um, if we want to find those constants, the a, the b, the c, and the d, we'd be trying to find the third degree polynomial that fits this data perfectly, if possible. Okay. Now, in order to do that, you have to get a system of equations, though. And so the way you get a system of equations is you have to plug in the 0 in here and see what you get. And so this condition, f of 0 equals -4, means if we go up here to the right-hand side of this equation and we put in x equals 0, well, you're going to have, instead of ax cubed, you're going to have a 0 cubed, right? We're plugging in 0. Instead of bx squared, we'll have b0 squared. Instead of cx, we'll have c0. Instead of d, we'll have d, because there's no x there, right? And so you plug in a 0 here, and we know that the result is supposed to be a -4. So you plug in your zeros, and you get 0 plus 0 plus 0 plus d equals -4. And let me open notes or something to type in momentarily. So when you work out this equation, right, all it really says is d equals -4. But hey, that's an equation, right? We already have one of the constants, right? We now know that d is -4. Um, but we have 3 other equations. So you have f of 1 equals -4. So if you put a 1 in here for x, then you have a times 1 cubed plus b times 1 squared plus c times 1 plus d equals -4. Or when you work that out, right, what this equation is going to be is it's going to be a, right, because a times 1 plus b times 1, which is b, plus c times 1, which is c, plus d times 1, which is d. Well, actually, there's no times 1. It's just d. And then it equals minus 4, right? And why does it equal minus 4? Because this was the data that we had. You do the same thing with the minus 1. So you have to plug a minus 1 into this equation. So when you do that, you get this. And that works out a little bit differently, right? Because negative 1 cubed is now going to be a negative 1. So when you do a times negative 1 cubed, you actually get minus a. And then you have b times negative 1 squared. But negative 1 squared is 1. So this is just b. C times negative 1, that's a minus c. And then we still have plus d, so plus d. And what is that supposed to equal? Well, negative 10 because we said so. Okay. Then your last equation, f of 2 equals 2. So you plug a 2 in for all the x's, and you get what we have here. But you have to multiply it out. So 2 cubed is 8. 8 times a is 8a. Then you have b times 2 squared. 2 squared is 4, so that's plus 4b. Then you have c times 2, that's 2c. Then you have d by itself, so that's plus d. And that all equals, according to this, 2. So these are your systems of equations. Now you have to be careful here. When you go to write out the coefficient matrix, right, you need the A, the B, the C, and D coefficients. So like up here, this just says D equals minus 4. But if you wanted to write it as like how we did this one up here, right, you actually have, even though they're not listed, you actually have a 0A, a 0B, a 0C, and then plus a 1D. And then on the next equation, right, it's 1A, 1B, 1C, 1D, negative 4. And of course, this has got negative 1A, 1B, negative 1C, 1D, and the last one is what it is. So when you go to write out the coefficient matrix, you do have to be careful that you are filling in zeros for the variables that don't exist, right? So the top row is for the coefficients are 0, 0, 0, 1. So 0, 0, 0, 1. And then your second row is 1, 1, 1, 1, 1, 1, 1, 1. And then your third row is negative 1, positive 1, negative 1, positive 1. And then your third row is 8, 4, 2, 1. 8, 4, 2, 1. And then that's your coefficient matrix. So when we go to type it in, it actually doesn't have it here. If I go, we can go to Octave and do this. So if I put in my A matrix like this is what it looks like. And then our B matrix is going to be the right-hand side of those equations, which I think we have them typed out here. Actually, they're here, negative 4, negative 4, negative 10, 2. So negative 4, negative 4, negative 10, 2 as a column. And then to solve it, right, we do x equals a backslash b like we've done already once. And look at that. So we get our solution. So these are the a, the b, the c, and the d to make a third degree polynomial go through these points. Okay, so it says here, let's double check. We have a 2, negative 3, 1, negative 4. 2, negative 3, 1, negative 4. So we have that right. Okay, and it says that's we find the coefficients. Now, just to double check that, let's go back over to Desmos here, and I can type in like y equals, and our coefficients are 2, negative 3, 1, negative 4. So that's 2x cubed. And then we have negative 3, so that's negative 3x squared. And then we have 1. So that's 1x. And then we have minus 4, which is just minus 4. And if you look at that, um, we have a problem. Did I type something in wrong? I should have gone through all the points. It's going through that one. 1, 2, 3. It doesn't go through this one. What is happening here? Oh, I just realized that when I typed in these numbers here, looking back at our notes here, those were both negative 4. 0, negative 4, 1, negative 4. But I typed the number in Desmos as 1, 4. So I'm like, why is it not going through here? Because it's supposed to be minus 4 down here. So if we look carefully, right, we see that it does go through all of those points exactly how it was supposed to. So it worked. We found the equation, right? So maybe I should modify this page here. And I'll just go down here, and where we solve it, it says these are the coefficients. But so the um, third degree polynomial that matches our data is
That's okay.
it's fine, there's nothing.
Okay, thank you.
Oh no, I paused the screen sharing, but I was trying to pause the whole thing. Let me unpause it. How do we do this? Oh no, where's the pause button? We're coming back as soon as I can figure out how to unpause. Okay, we're back. Okay, so sorry about that. Anyway, where were we? So um, we were writing out the polynomial. So the third degree polynomial that matches our data was, as we discovered, I'll say f of x equals, and these are the coefficients. So it's 2x to the third power minus 3x squared plus x minus 4. And that would be kind of the final answer there. So just wasn't listed there until now. Let me click save and actually save that page. All right. So there we go. So you just fill in the numbers into the A, B, C, and D, and that's the third degree polynomial that matches our data. And so you have to do that a couple of times in the lab, um, and you can, and it's fine. Now, but guess what? There's actually a built-in function that can fit a polynomial to our data. And so that's the other thing that we could do, and it's like one line. So this is formally what happens behind the scenes. There's a system of equations um, that we have to solve in order to find the coefficients A, B, C, and D. But we can do it a different way. So there's this command called polyfit built into MATLAB in Octave. And the way it works, and you can see here, is you just give it your X data, which are just the X values. You give it your Y data, which are the Y values, and you give it the degree of the polynomial that you want to fit. So you have to make sure you know what degree polynomial you're trying to put in. And we can solve the same problem. Now, think about how much work this was. This wasn't a huge amount of work, but it was a little bit of work, right? I had to plug in the zeros and the ones and the negative ones and the twos, and I had to write out this system of equations. And then I had to come over to Octave and I had to like type in this coefficient matrix and I had to type in the constant vector. And then I could solve for the 2, the 3, the -1, and the -4, right? That was the steps. But with polyfit, there's an easier way. So with polyfit, and we can check out the documentation for this, by the way, right? We can say help polyfit. Um, and hmm, polyfit. I don't know. I think I just don't have the I was going to say I don't have the documentation, but it looks like I do. So I type doc polyfit and I can read down here some help on how to use the polyfit function. We could also Google and find information about that, but I'm not going to read the documentation now. We'll just we will just finish solving this. So how does polyfit work? Well, you can see the command is listed here. So polyfit, and it says X data, Y data, degree. So all you have to do is type in your X data, which you can call X or, X data if you want. And what's the X data? Well, the X data is just the X values over here. So like what went into the function f are 0, 1, -1, 2. Those are your X values. So you just put them in a vector. You just say 0, 1, -1, 2. There you go. You do the same thing for your Y values, which are your function values. So Y data equals -4, -4, -4, -4, -10, 2. -10, 2. So those are your Y values. And then in order to fit your polynomial, all you have to do is call polyfit. So as it says down here, this is the way you call it. You can say P equals, get the polynomial in a variable, but it's polyfit, and you give it your X data, you give it your Y data, and you give it the polynomial order. Now, you have to be careful here, right? If I type 1, or actually if I type 0, that's a 0-degree polynomial. That's a constant. This is not really what I want, right? If you put in a 1, that is a second-degree polynomial. Again, that's probably not what I want. Um, so you have to make sure that you're paying attention to what degree you want. So if I was trying to fit this, I'm trying to fit a third-degree polynomial to our data. So I have to type in, make sure that I put a 3 here. Otherwise, I'll be doing a different degree than I want. And so if I type a 3, I get 2, 3, -1, -4. Exactly the same thing that I had here. 2, -3, 1, -4. 2, -3, 1, -4. And so this, remember, so did this involve just typing in the X values, typing in the Y values, and then running polyfit. And so that saved us from having to manually write out the system of equations. And so what you've got going on this week in class is in the lab, not here, in the modules, we'll go home. In the lab today, here, you're going to be solving what? I think, let me reload this. Okay. So we'll be solving some system of equations. You have to type them in and get the answer. This is just like what we did, but in here it says set this up as a system of 4 equations and solve for the unknown coefficients. And same thing here. I want you to solve it by writing the system of equations down. That's the first way that we did it. However, in the homework for this week, homework 4, um, then I have 2 of the same problems, but this time it says instead of solving the system equations by hand, use the polyfit function. So we want to use the polyfit function as I just demonstrated. So this is actually really quick. I just want to make sure that you know how to type this out and solve it with the polyfit method of solving it. And then there's another question here that's unrelated that I want you to go find and solve from a textbook. Um, all right. Well, anyway, I think that's it for this lecture. Hopefully it was helpful. Sorry about the not successfully pausing it, but it was only in a minute, right? So it'll be fine. All right, that's it for this lecture. Talk to you guys later.